Okay, let us continue with the examples. What is the next one? Without root. So next example is without root. 1 by 9x square. It is 1 by 9x square plus 6x plus 5 plus 6x plus 5. So we need to integrate this one. So let's just try to integrate it. So therefore you can rewrite this as integral I is equals to, it is integral of 1 by 9x square plus 6x plus 5 times of dx. So further, if you try to simplify this one, it should be in the form of a plus b whole square. So what I'll try to do is, I'll just try to rewrite this one. It is, if you want, you can do it in the working column. You're having 9x square plus 6x plus 5. So I can rewrite this value to be equals to, it is 3x whole square, which is in the form of a square plus 2 into a. A is 3x. So if you try to multiply, so it is 2 into 3x. So how much it will be? 6x only. So what about b value? B value is not there. Therefore, I had to write into 1 plus it is 1 square minus of 1 square. This is how you can just group this one. So let's try to group that one and put it over here. We got the integral as integral of dx by, this has become 3x square plus 2 into 3x into 1 plus this 1 square, and this minus of 1 square will remain as it is. Or further, if you try to simplify this one, it is dx by this plus 5, and this plus 5 has to come here. That plus 5, right? Now, okay, now we'll try to group this one. Group this part, first 3 terms. So first 3 terms is in the form of a square plus 2ab plus b square. We know a square plus 2ab plus b square will be a plus b. A value is 3x plus b value is 1. So it is 3x plus 1 whole square. It is a plus b whole square. Here you can observe that this value of this plus 1 and minus of 1 will cancel out and will be left out with this value plus 5 over here. So it is integral. Now I need to use the substitution method to integrate this one. So put the value of this 3x plus 1 to be equals to t and try to differentiate this one. 3 as it is, derivative of x is dx plus the constant 1, derivative will be 0, is equals to dt. Or if I ignore that 0, I'll just be left out with dx is equals to dt. Cross multiply that 3, so it is dt by 3. Now if I just try to plug in back there in the given integral, dx will be dt by 3 whole divided by 3x plus 1 is t square plus, both the terms should be in the form of square. So 5 can be written as root 5 whole square, so that it is in the standard form. However, in the numerator, 1 by 3 is a constant outside. You are left out only with dt by t square plus root of 5 whole square. So we know this standard formula. It is integral of dx by x square plus a square. The first formula, 1 by a tan inverse of x by a plus the constant c. So let us try to use this one. I is equals to 1 by 3. So now integral value is what? 1 by a. What is a in this case? This will be acting as your a. A will be root 5. And over here, x value will be nothing but t. So if I just try to plug in here, 1 by a value is root 5 into tan inverse of x. X value is t by a value is root 5 plus the constant c. But what is the value of t I have taken? The value of t that I have taken over here is 3x plus 1. So just plug in that value. 1 by 3 root 5 tan inverse of 3x plus 1 divided by root 5 plus the constant c. So it was 3x plus 1, right? Yes, t value was 3x plus 1. So hence we have got the required solution.